Welcome to Foundation Mathematics, Essential Background 1, Terms and Rules of the Algebraic Language. The objectives for this session are to briefly look at numbers, letters and symbols, understand the words term, expression and equation in the context of algebra, explore algebraic terms, conventions and shorthand, learn to use the BODMAS rules, apply rules relating to negative numbers, and understand and apply the commutative, associative, and distributive laws. We will begin by taking a look at numbers, letters, and symbols. In mathematics, letters can represent general numbers. We can describe a rule that applies to all numbers. So, for example, instead of giving multiple numerical examples of how 2 times 3 and 3 times 2 mean the same, we can replace these specific numbers with letters that could represent any numbers. So, for instance, we have the rule A times B equals B times A. Which letters should we use to represent numbers? In a real situation where the letters represent the value of something known, choose letters reminding us of that thing. So, for example, let C equal the number of cats my neighbour has. So, in this example, we have 3 cats, and therefore C equals 3. Let's now take a look at a more involved example. Suppose that the only pets my neighbour owns are cats or dogs. Let C equal the number of cats my neighbour has, and let D equal the number of dogs my neighbour has. Then the total number of pets, P, my neighbour has, is given by P equals C plus D, so the number of cats plus the number of dogs. If C equals 3 and D equals 4, then P equals 3 plus 4. So P equals 7. Letters from the end of the alphabet, such as X, Y, and Z, are used to represent some number that can have a range of values. Such a number is called a variable. So, for example, let X equal the income of an employee in a company. This is a variable because it varies from employee to employee. Let's now take a look at symbols. Symbols are a vital part of the language of algebra. We will revisit symbols in another session. In this session, we focus on how we combine letters and numbers. For now, simply think of symbols as being plus, minus, and equals, but we will expand on this in a later session. Rules help us to decide what to do with a mixture of numbers, letters, and symbols used in algebra. The rules known as BODMAS tell us the order we deal with the items in a mathematical expression. We will now take a look at terms, conventions, and shorthand in algebra. The language of algebra can be illustrated by using this example shown on your screen. The letters represent numbers. Remember that the letters could be fixed or variable, but usually, as we mentioned earlier, X, Y, and Z will represent variables. Notice that there are no multiplication or division signs in this equation. This is because multiplication is represented by putting the number next to the letter or letters. So 3 times x equals 3x. Furthermore, numbers are placed before the letters. This means that if we have y times 5, we would write this as 5y. And letters are positioned in alphabetical order. So if we had 25 times z times x times y, we would write this as 25xyz. An algebraic term is a small group of numbers and letters with no symbols, as shown here. An algebraic expression does not have an equals sign, as shown here and here. And an algebraic equation does have an equals sign, as shown here. Let's now take a look at the BODMAS rules, or the order of operations. Before we begin, let's make a note of brackets in your calculator. The brackets shown on your screen are usually used by computer algebra systems and spreadsheets. These brackets in the next line usually denote a set, and the square brackets are usually kept for a special purpose. In mixed operations of addition and subtraction, it is generally easier to do the addition first and then the subtraction. Let's look at an example. Try solving 96 plus 28 minus 54. Now, when considering this sum, do the addition first. 96 plus 28 equals 124. And putting that together with minus 54 gives 70. Now let's take a look at another example. Try solving 96 minus 54 plus 28. Rearrange the values so that the positive values come first, as shown. Doing the addition first gives us 124 minus 54, which equals 70. In mixed operations of multiplication and division, carry out the division first and then the multiplication. Let's look at an example. Try solving 90 divided by 15 times 4. Carry out the division first. 90 divided by 15 times 4 gives us 6 times 4 to give 24. What if we had done the multiplication first? Let's do that. Consider then 15 times 4 first. This gives us 90 divided by 60, which equals 1.5. The value of the same line is different depending on whether we do division first or multiplication. So order is important, otherwise we will get different answers. We must always do division first and then multiplication. BODMAS is a useful acronym which informs us which mathematical operation should be performed first. First, we carry out the operations inside the brackets. Then we carry out the orders or powers. Then division, then multiplication, then addition, and finally subtraction. Let's take a look at an example. Consider the one shown on your screen. Carry out the operations within brackets first. 20 times 4 is equal to 80. We substitute 80 in place of 20 times 4. Now see if there are any orders or indices or powers. There is an order or power, namely 3 squared. This equals 9. We substitute 9 in place of 3 squared. Now see if there are any divisions. There is a division, namely 100 divided by 80. This equals 1.25. We substitute 1.25 in place of 100 divided by 80. Now let's see if there are any multiplications. There are no multiplications, so we move on to the next operation, namely addition. The additions are highlighted as shown. We rearrange so that all the additions are at the beginning and the subtractions are at the end. Now 1.25 plus 9 plus 5 equals 15.25. So we replace this with 15.25. Finally, we are left with the operation of subtraction. We have 15.25 minus 7 left at the end. And this equals 8.25. Let's take a look at another example. Consider the one shown on your screen. Carry out the operations within brackets first. 8 minus 3 is equal to 5. We substitute 5 in place of 8 minus 3. Now see if there are any orders or indices or powers. There is no order or power, so we move on to the next operation, namely division. There is a division, namely 20 divided by 5. This equals 4, and we substitute that in place of 20 divided by 5. Now let's see if there are any multiplications. There is a multiplication, namely 4 times 5. This equals 20. We substitute 20 in place of 4 times 5. And we move on to the next operation, namely addition. The addition is highlighted as shown, and this equals 35. Since we now have a numerical answer and no more operations, clearly there is no point in considering the last remaining operation, subtraction. So there is nothing to consider now at all. So our final answer is 35. Let's now take a look at some algebraic rules and laws. We begin with negative numbers. Negative numbers can be thought of like a debt. So for instance, minus £5 represents a debt of £5. Debts added together will make the debt bigger. So minus £2 minus £4 equals minus £6. Multiplying a debt by a number greater than 1 makes the debt bigger. So 7 times minus £2 equals minus £14. Debts can be wholly or partially cancelled by adding credit. So minus £7 plus £8 equals £1, and minus £7 plus £5 equals minus £2. Negative and positive numbers are multiplied using the following rules. Rule 1. Plus times plus, such as 2 times 4 equals 8, is plus. Plus times minus, such as 2 times minus 4, is equal to minus 8. So minus. Minus times plus, such as minus 2 times 4, is minus 8, which is a minus. And finally, minus times minus, for example, minus 2 times minus 4 equals plus 8, or plus. Now let's take a look at divide. Plus divided by plus, for example, 4 divided by 2 equals 2, is plus. Plus divided by minus, such as 4 divided by minus 2 is minus 2, so minus. Minus divided by plus, such as minus 4 divided by 2 equals minus 2, so minus. And minus divided by minus, for example, minus 4 divided by minus 2 equals 2, or plus. Negative and positive numbers can also be added and subtracted. Rule 2. Adding a positive number is the same as subtracting a negative number. So for example, plus 4 equals minus 4. Also, adding a negative number is the same as subtracting a positive number. So for example, plus minus 4 equals minus 4. Let's now take a look at some rules and laws in maths. In maths, a rule is something which is followed for convenience, and a law is something which is always true. Consider the commutative law. An operation is commutative if it doesn't matter which order you put the numbers. So for example, 2 plus 3 equals 3 plus 2. And generally, a plus b equals b plus a. We also have 3 times 4 equals 4 times 3. And generally, a times b equals b times a. Or ab equals ba. So the commutative law on addition is a plus b equals b plus a, and the commutative law on multiplication is ab equals ba. There are operations which are not commutative. So for example, subtraction is not commutative. 3 minus 1, notice, is 2, and 1 minus 3 is minus 2. So 3 minus 1 does not equal 1 minus 3. Also, division is not commutative. For example, 3 divided by 4 does not equal 4 divided by 3. Now let's consider the associative law. Consider this example. 2 plus 3 plus 4 equals 2 plus 3 plus 4. More generally, a plus b plus c equals a plus b plus c. Now consider this example. 4 times 5 times 2 equals 4 times 5 times 2. More generally, a times b times c equals a times b times c, or ab times c equals a times bc. So the associative law on addition is as shown, and the associative law on multiplication is as shown here. There are operations which are not associative. So for example, subtraction is not associative. Let's take a look at this example. On the left-hand side, we have 3 minus 1 minus 4, which is equal to 2 minus 4, which is of course equal to minus 2. And on the right-hand side, we have 3 minus minus 3, which is equal to 6. And of course, minus 2 does not equal 6. So subtraction is not associative. We've found a counterexample. We also have that division is not associative. For example, 3 divided by 4 divided by 5 does not equal 3 divided by 4 divided by 5. This is because on the left-hand side, we have 0.75 divided by 5, which is 0.15. And on the right-hand side, we have 3 divided by 0.8, which is 3.75. And clearly, the left-hand side and the right-hand side are not equal. Therefore, division is not associative. We will now take a look at the distributive law of multiplication over addition. We have that a times b plus c equals ab plus ac. We will now use the BODMAS rule to verify the distributive law by using the example shown on the screen. Let's do the brackets first. Eight plus 3 equals 11. Now let's do the next operation. This is multiplication. 5 times 11 is 55. Now let's consider the right-hand side. Do the brackets first. In each of the brackets, we only have multiplication. So 5 times 8 is 40, and 5 times 3 is 15. Now let's consider the last step. There is only addition left, 40 plus 15. And this is equal to 55. So the left-hand side equals the right-hand side equals 55. And the first distributive law holds. This brings us to the end of this session. If you have understood its contents, you should be able to recognize numbers, letters, and symbols, understand the words term, expression, and equation in the context of algebra, explore algebraic terms, conventions, and shorthand, use the BODMAS rules, apply rules relating to negative numbers, and understand and apply the commutative, associative, and distributive laws. Thank you very much for listening. For a deeper understanding, do attempt the exercises in your textbook related to this topic.